SwayamPrabha. Digital India. Educated India.
The fourth sensor which we will be discussing will be magnetometer. As the name suggests, it has to do something with magnetic field something. That's right. Magnetometer basically measures your magnetic field. Now suppose I have a conductor. This is my conductor and I pass a current through it. This is current. This is your I. The electrons will flow from one side to another side if I apply a voltage. This is a simple phenomena where I apply a current to a conductor, the electrons will flow from one side and it will come and the circuit will be completed. But as you know, if there is no magnetic field in this conductor and I have given a constant current to this, I am giving a constant current to this particular conductor, and if there is no magnetic field, if I measure potential of this particular surface, it will be 0. In presence of magnetic field, this line will get distorted, so it will be something like this. Assuming I am giving this constant current, then voltage will be some VH. This is known as Hall voltage, and this whole phenomena is known as Hall effect. Now your major magnetometer sensors which come in for your MEM sensors, you can call it, or for UAV applications, use this phenomena or Hall effect for calculating your earth magnetic field. In UAV application, magnetometers are used to calculate or to find your magnetic north, which is different from your actual north. Now the magnetic north constantly varies according to your location, magnetic north. Now this magnetic north will constantly vary according to a particular location where you are. Means if you have GPS data, then there are data available where you can give a correction factor to align your vehicle to true north. The major application of using magnetometer is that it has zero biasing effect, or means zero error. Means if you have given your UAV to head to a particular direction, say a particular heading you have given, so since your magnetometers have zero error, so it will automatically correct your heading, automatically correct your heading angle. So that's why it is very good for UAV application when you are focusing on particular direction in which your UAV has to follow. But the defect of this magnetometers are, since a magnetic field is involved, so there are different instruments or different equipments in UAV or in plane itself which are which have electromagnetic fields, such as you cannot mount a magnetometer near a rotor because it has a magnetic field, so it can distort your readings. And also when you have a large landing gear which is metallic, the problem comes of magnetic field. That's why this the mounting of magnetometer has to be considered where it should be mounted, so your electromagnetic field does not vary. Now these were regarding to your accelero, gyro and magnetometers. The three sensors which we discussed now were accelero, rate gyro and magnetometers. Usually you will find circuits where these all three are available on a single unit. We usually name it as IMU or inertial measurement unit. For our experimental purpose, we will be using MPU 6050 and 9250. These are very simple IMUs which are available in the market, and will be in this lecture we'll be showing you how to capture data using IMUs 6050. This was regarding to inertial measurement unit. Now we'll be seeing what are angle of attack sensors and why angle of attack sensor is needed. So the next sensor will be angle of attack sensor. As you already know, angle of attack is your angle between, this is a section of your wing. When I connect your leading edge to your trailing edge, this is known as chord line. This is your free stream velocity. These are all parallel, and the angle which this free stream velocity makes with your chord line, that is your angle of attack represented by alpha. Now why we need to calculate angle of attack? Because it helps in stall warning systems. Alpha angle of attack sensors are basically of two forms. Sensors. Second is your sensor. Now first we will be discussing what are vane type of sensors and what are pressure type of sensor, both angle for angle of attack. First, vane type. Vane type of angle of attack sensors, the properties are, first A, these are small airfoil type, small airfoil shape, which are free to rotate. Second, they line up relative to airflow. Now since they line up relative to airflow, so they cannot be mounted in downwash areas such as just behind your wing, downwash. And D, as it is free to rotate, the rotation is calibrated through a potentiometer, and we will be getting voltage with respect to rotation of this vane type of angle of attack sensor. Now this was for a vane type of angle of attack sensor. This is a small angle of attack sensors used for small UAVs and small aircraft. Now the principle is same as of vane type of angle of attack sensor. Here instead of vane, a small flag is there. As you can see, this will align when the aircraft will be moving in the air. This will align according to particular airflow. Now suppose it aligns in this particular direction. Now you can see this is mounted and it can rotate, and based on that rotation a potential will be generated which we can sense or calibrate according to this particular relation. As you saw for while calibrating your control surfaces, the same phenomena was used. While deflecting the control surface, there was a potentiometer involved, and based on that a particular voltage we got in LabVIEW program. Same principle is used here also. Based on the deflection, your rotation of potentiometer, the voltage will be generated, and that can be calibrated according to particular angle of attack. And as you know, these angle of attack sensors is majorly used for stall warnings. So this is beneficial in that. Now second type of sensors which will be using, second type of angle of attack sensors are pressure type of sensor. Now what are pressure type of sensors? Pressure type. Sensors. Now pressure type of angle of attack sensors, it involves airfoil section blade, and the holes are mounted at the leading edge symmetrically below and above that particular surface. Now as air will flow, this particular air, as your angle of attack will increase, will create a pressure difference. This is your chord line, or this is your chord line. Here suppose angle of attack is 0, here angle some positive value. This pressure difference can be transformed into a voltage signal using some transducers, and that can be calibrated voltage signal through transducers, and this voltage signal can be calibrated for angle of attack. So these are two types of angle of attack sensors. Now most of these small UAVs don't use angle of attack sensors because it is not much needed. Usually they fly at much lower angle of attack, so they don't reach that high of a stall value. So this is not required in small UAV applications, but for commercial aircraft this is an important sensor, so we cannot just neglect this sensors. Now so far these were the sensors which you saw in flight data recorder other than your magnetometer. Now one more type of sensor which I want to discuss is your GPS, because nowadays it has quite a lot of applications, starting from your UAV operations to your smartphones. You have GPS everywhere and it's helping lot of people. Now what is GPS? As commonly known as, or all of you know that it is global positioning system. Yes, this is a full form, but what does this represent? It is actually a constellation of many satellites which revolve around the earth in a fixed orbit, such that each and every location on this earth has access to at least 4 of these satellites. At least 4 are available for every position on this earth. Now question arises, why 4? Because if you have access to one satellite, you can determine a point in one dimension. With two satellite, 2 dimension, 3 dimension, and that's all we need. So why this 4th satellite is required? We'll be coming to that. let us understand how GPS access a particular point and why these 4 satellites are required. Now the phenomena which is used to access a particular point is trilateration. Trilateration. What do you mean by trilateration? Now all these satellites which are revolving around the earth in particular orbits have their clock synchronized every day. That is your accuracy, these are atomic clocks, so accuracy is very high. These are as high accurate as 1/1,000,000th of a second. These are synchronized every day from Earth. Now each and every satellite sends 2 data to receiver, GPS receiver, that is its location, second time at what it was sent, time, okay, it was sent. Now when this satellite sends its location to particular receiver, say this is receiver, this is your satellite A, this is your satellite B, and this is your satellite C. So this, when this satellite sends its signal to this particular satellite, so it will calculate the distance of this satellite using a simple formula. Distance equals to speed into time. Here time will be time at which the receiver got its signal minus time at which the satellite sent this signal, and here speed is your speed of light, meters per second. Now as you can see, with one particular satellite it will be, now as you can see, using this formula it can calculate distance at which from which it got its signal, or your receiver got its signal. So for satellite A, suppose the distance was some d1, this is d1, so it can be anywhere along this particular circle. This is a circle of radius d1, this is a circle of radius d1 for satellite 1, so your point can be anywhere on this particular circle. But since this is in space, so this will be a whole sphere, this is a sphere, so your point can be anywhere on this particular sphere. Now the distance received, distance for satellite B, that will be also calculated using same formula. Suppose this will be distance d, so another circle with distance d2. Now intersection of this sphere and this sphere will give you this particular circle. Intersection of these 2 sphere will be a circle. I will represent that with a small circle, that is, say suppose this was a circle, intersection of these 2 points. So your object can lie anywhere on this whole circle. Now suppose this C, this is your third satellite, and it will also, the distance will be calculated using that formula, and therefore it will be circle somewhere like that. So you got 2 points, this and this. Now since you are on Earth, this will act as a 4th point, since you cannot be in space, so this is your location. So from here it seems that you only require 3 satellites to get your particular location. So what's the need of 4 satellites? The 4 satellites plays a role of accuracy. Now you know this is a time at which receiver got your signal, and this was the time at which your satellite sent signal. A small, even a small difference of say 10 to power minus 6, delay of 10 to power minus 6 second will result in 3 into 10 to power 2, that is 300 meters error. So that's why you require at least 4 satellites, so that this error is significantly reduced. And the more number of satellites are connected to your receiver, the more accurate will be your data. And other parameters such as height and ground speed can also be calculated using your GPS data, but that's not for this course. So I will be concluding up to this portion. So as far as for sensor part, these were the major sensors which I wanted to discuss and let you have an idea how these sensors work, what are general principle, and how data acquisition data are acquired using these sensors. So that will be demonstrating you with a small examples. We will be also sharing you the code for accelerometer and your rate gyros, as well as for angle of attack, which I already showed you a small angle of attack. We will be sharing you code and showing you how it does you acquire data using an Arduino board and MPU 6050 sensors and angle of attack sensor. Thank you.